Hello from ChemHelp ASAP. In this video we're going to discuss the formula for calculating formal charges. Formal charges are a vital idea in organic chemistry, and being able to calculate the formal charge on an atom will give you very valuable information for determining how that atom is going to behave in a subsequent reaction. So calculating formal charges is not a punishment. It's a way for you to gather information about what your molecule is going to do and how it's going to react. Okay, so what is the formal charge? The formal charge is something we use to determine whether an atom has an excess or deficiency in electrons. We're really talking about, we're only going to deal with valence shell electrons. Okay, so there are formulas to calculate this, and there are a lot of different formulas. They all reduce to the same things, but there are different ways that people express them. But for us, we're going to focus on the fact that the formal charge, our equation, is going to try to get at the idea that there is a number of electrons that the atom should have. So there's an ideal number, and then we're going to subtract away the number of electrons that the atom does have in the molecule. So what should it have and what does it have? And what we're going to see, if the atom has too many electrons, our formal charge, Fc, is going to be less than 0. It's going to be a negative number. If there are too few electrons, our formal charge is going to be greater than 0. We're going to have a positive charge on that element, on that particular atom. And ideally, we're going to have the just right formal charge, and that is going to equal 0. So there's an ideal number for formal charge. However, not all atoms in molecules have a formal charge of 0. Fortunately, in organic chemistry, it will typically be the case that stable molecules have a formal charge of 0. So what's our big equation? Formal charge. Formal charge equals the number of valence electrons in a particular atom. So if we're looking at carbon, carbon has 4 valence electrons as an atom. We get this from the periodic table. We don't have to calculate this. This is just a reality for that particular atom. This is what the atom should have. We get that, read that off the periodic table. And then we subtract from that number the number of electrons in lone pairs. Some people say it's 2 times the number of lone pairs. Some people just say count the electrons in lone pairs, exact same value. And then we subtract out 1/2 of the number of electrons in bonds to that atom. So these are covalent bonds. Those electrons are being shared, so the atom only gets to count half of those electrons. And this equation will allow us to determine the formal charge on an atom. It's a really important number to be able to calculate. Over time, you'll see it instinctively. It won't be a calculation, but it will take time for that to occur. This is, again, a vital skill, and it provides valuable information for how your molecule will react. And in a subsequent video, we'll see examples of how to apply this equation.